Okay, this is video part 2 for the distributive property. Now, one of the things that we need to talk about with the distributive property before we get into more difficult problems is like terms. We need to talk about how to combine like terms. Well, first, before we can do that, we need to define a couple of terms. So, in an algebraic expression, a term is a number, a variable, or the product means multiply, of one of each, a number and one or more variables. So, for example, a term could be 6 because it's a number. A term could also be x because it's a variable. We could also have 4ab. This is also a term because this has one of each. This has a number and, well, actually 2 variables, not one of each. This one has 2. Okay, so this is very important to know when the teacher says term, what a term means. Okay, so any term that does not have a variable, such as this 6 right here, is called a constant. So he's alone, he's constant, nobody's with him, okay? A coefficient is, listen to this, a numerical factor of a term. What does that mean? Well, basically that means that a coefficient is the number in front of a variable. So if you have a number and a variable paired together like this, then this number right in front is referred to as the coefficient, E-F-F-I-C-I-E-N-T. Okay? Very important things for you to remember. Okay, so you need to know this in order to combine like terms. Like terms have exactly the same variable factors, okay? So the same variable. All right. Let's flip over to the back. Like or not like. So I'm going to give you a couple pairs of terms, and I'm going to ask you if they are like terms or not like terms. So let's see. I have x. No, I have 2x. And I have 4x. Are these like terms? Decide for yourself. Yes, these are like terms. These both have the same variable. They both have an x, okay? The coefficient in front, those, yes, are different, but that does not matter. As long as they have the same variable, that's what counts. So if I were to add these, I would then have 2x and 4x. Think about it like 2 pencils and 4 pencils. Then I'd have 6 pencils, okay? That x just represents something that we don't know, all right? Let's keep going. How about 5 and 12? Are those like terms? Well, you might be saying to yourself, well, neither one of them have a variable. Well, that doesn't matter either. Constants are considered like terms. So if neither one of them have a variable, then yes, these would also be like terms. You would combine these two. All right. So 5 and 12 would be 17. All right. Let's think of another one. How about if I say b and b squared? Think about that one for a second. This actually would not be like terms, okay? Here's why. Yes, they have the same variable, but the exponent matters as well. So this one has the exponent, well, none, you would think, but this has the exponent of 1. It's just b once. This is b squared, so this is like saying b times b. These are not the same, okay? So you cannot combine these. You might be asking yourself, well, what happens if I can't combine them? Then they just stay apart and you rewrite it. B plus b squared. Okay? If you can't combine them, you can't combine them. Just leave it the way it is. All right. How about 4n plus 8? Are these like terms? No, these are not like terms. This one has a variable, this one doesn't have one at all. So once again, if you can't combine like terms, you just leave them the way they are, 4n plus 8. That's the best you can do. This would be considered already simplified. Nothing else to do to this, okay? And how about 3x and 4y? Are these like terms? They both have a variable, but not the same variable, so no. And once again, you would just leave it the way it is, 3x plus 4y. Nothing else you can do. All right, let's look at some examples. Number 115, I have 6r plus 8r. I need to combine like terms. These are like terms because they both have the letter R, so it's just like saying 6 rulers plus 8 rulers. I've got 6 of them and I get 8 more. Now I have a total of 14 R or 14 rulers if you'd like to think of it that way. Okay. Let's look at 117. Let's just go right down. Let me zoom in a little. We have n plus 6 plus 5 plus another n. So these two n's will be considered like terms. And then these two constants will also be considered like terms. So we need to combine the ones that are alike. N plus n. Well, this is 1n plus another n would be 2n. A lot of people, when they're faced with this, they say n squared. N squared is not an okay answer. That would be if you had n times n. Remember how your exponents work. Plus, now you need to add your constants. 6 plus 5 is 11. Can you combine terms anymore? No, you can't. These are not like terms, so this would be your answer. Okay. Let's go straight down once again. Negative 7a plus 4. Are these like terms? No, they are not. We have a variable here, no variable here. So this is a coefficient and a variable. This is a constant. They are not alike. So there's nothing we can do here. It's just 7a plus 4. Hopefully this is making sense. On the bottom half, this is the same thing. This is incorporating a lot of stuff though. We need to distribute and combine like terms. So I have 6 problems here. I'm gonna do 2. I want to challenge you to try most of these on your own. So I'm going to do 121 and 125. I'm thinking, yes, that should be fine. I think with those 2 examples on your paper, you should be solid on solving the rest. So let's get started. Here in my first part of this problem, the first thing I need to do is distribute this 9 inside of the parentheses. So let's do that first. 9 times negative 10b. So even though 9 doesn't have a variable, it doesn't matter when you're multiplying. You can just multiply the constant and the coefficient. So 9 times negative 10 is negative 90. Don't forget the b comes along for the ride. Then we have 9 times 10 again, minus 90. And that's everything in the parentheses. Then we just need to make sure we don't forget about the plus 7b on the outside. Okay, now we need to combine like terms. Our like terms are this negative 90b and the 7b. They both have a b for a variable. So we need to combine.